Exercise 2.22. Two perpendicular vectors u and v lie in the xy plane. The vector u is equal to 6 units in the I direction minus 8 units in the j direction, and the magnitude of v is equal to 20. What are the components of v? So, as always, the first step is to write down the information that the problem is given to us. So I have a vector which is equal to 6 units in the I direction minus 8 units in the j direction. For those of you who may be asking why do I write down this like this, is because this is referring to a vector and this to its components. So that depends on the author. And then I have that the magnitude of the vector v is equal to 20. They're asking me for the components of v. So they're asking me for the vx component in the I direction plus the vy component in the j direction. Specifically, they're asking for me to give these two. Alright, let me put this exercise a little bit more graphical. So right here I have the y-axis and right here I have the x-axis. The x-axis towards this direction is going to be positive, and the y-axis towards this direction is going to be positive as well. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. That would be enough. So right here I have 1, 2, 3, 4, 5, 6. 6. Right here I have 1, 2, 3, 4, 5, 6, 7, 8. Minus 8. That means that the vector that the exercise gave to me will be this one. You know, 6 positive units along the x direction minus 8 units in the j direction, right? So this is u. Now they're telling me an important or a keyword: perpendicular. Perpendicular means 90 degrees. So I should be able to find a vector that is 90 degrees with respect of u. So here's going to be this one, for example, v. But this is not the only vector that generates a 90-degree angle with respect of u, because right here I have another one. And they are telling me, hey, you should use the positive or you should use the negative. They're asking me a 90-degree angle. So that means that this answer is valid as well as this one. That means that this exercise has two different valid answers. So I know that I should be able to maybe close this triangle, maybe start playing with this angle or this angle, and find this find this one, start playing with different like trigonometrical equations for me to find this dimension, which is going to be the vy dimension, and this dimension, which is going to be the vx dimension. But there is one thing that is called the unit vector. The unit vector is a vector which magnitude is equal to 1. So the magnitude of A is equal to 1. It is always represented by this little hat. That means that if I have, for example, this vector, which I'm going to call A, and this is the unit vector of this A vector is going to be this one. So there is two ways in which I can find a unit vector. The first way is by using its components. So for example, the vector A is equal to AX in the I direction plus AY in the J direction. The unit vector will be equal to AX divided by the magnitude of A in the I direction plus AY divided by the magnitude of A in the J direction. There is as well one other way for me to find the unit vector of A, and it's by using the angle generated between the vector and the axis X, and that is by using the cosine of the angle in the I direction plus the sine of the angle in the J direction. Alright, now that I've made this clear, why do I use it? Because the unit vector could be used for me to transform the vector. So what we're going to do is to transform this vector 90 degrees with a magnitude of 20, and that is going to be equal to the v vector. Alright, so we're going to do it. First, we should find the magnitude of u. So the magnitude of the vector u is going to be equal to the square root of 6 squared plus minus 8 squared. So the square root of 6 squared plus minus 8 squared is equal to 10. Now that we have that, we're going to find the unit vector of u. So the unit vector of u is going to be equal to 6 divided by 10 in the I direction minus 8 divided by 10 in the J direction. That is equal to 0.6 minus 0.8. Now we're going to find the unit vector taking into account the angle. So we should be able to find this angle that I'm going to call, for example, alpha. Right here we have alpha. Right here I have 8. Right here I have 6. And right here I have 10. Neither this angle or this angle I have the magnitude, but I have the 3 cathetos of the triangle. So it is easier for me to find the angle that I need using the cosine law. For those of you who do not remember how to develop the cosine law, I'm going to refresh your memory. The first thing that you have to know is that you should use the opposite magnitude of the angle that you want to find. In this case, it's 8. And from there, you're going to construct the equation. So you're going to use the other 2 cathetos evaluated to the second power added, minus 2 times, once again, the other 2 cathetos, multiplied by the cosine of the opposite angle. For example, if I have right here V8, I should use the opposite angle, in this case alpha, the angle that we require. All right, we have the entire equation, one unknown. We can't find that unknown. I'm gonna do it step by step for you to not be lost during the solution. So 8 squared plus 2 times 10 times 6 times cosine of alpha is going to be equal to 10 squared plus 6 squared. 2 times 10 times 6 times cosine of alpha is going to be equal to 10 squared plus 6 squared minus 8 squared. The cosine of alpha is going to be equal to 10 squared plus 6 squared minus 8 squared divided by 2 times 10 times 6 times nothing. Finally, the angle is going to be equal to the cosine related to the minus 1 of this 10 squared plus 6 squared minus 8 squared divided by 2 times 10 times 6. Finally, the angle is going to be equal to the minus the cosine related to the minus 1 power of 10 squared plus 6 squared minus 8 squared divided, divided by 2 times 10 times 6. Right? Alpha is equal to 53.13 degrees. Fifty-three point 13. Right, now that we have the angle that is generated between the vector and the x-axis, I should be able to find the unit vector of u in terms of the angle, as we did right here. And that is going to be equal to the cosine of 53.13 in the I direction minus, and I use minus because along the y direction I have the negative part right here and the positive part right here. The sine of 53.13 along the j direction. All right, we have everything we need. Now we have to add or subtract 90 degrees because we are transforming that vector. So plus or less 90 degrees, I'll have a solution for the vector b. So the first solution for the vector b, the unit vector v, is going to be equal to the cosine of 53.13 plus 90, 143.13, the I direction minus sine of, once again, 143.13 in the j direction. Remember, all we have to do is to add to this equation 90 degrees, but it's the same equation. Now we're going to subtract 90 degrees for the second solution of the vector of the unit vector b. The unit vector b is going to be equal to the cosine of, in this case, I'm gonna subtract it, so minus 90 minus 36.86 in the I direction minus the sine of minus 36.86 in the j direction. But this has a solution, right? This is actually a number, this 4. So this is going to be equal to the cosine of 143.13 and that means that this is equal to minus 0.8. I can approximate this number to 0.8. Minus the sign of the same number minus 0.6. All right, I forgot to write down the directions, so I, J. And we're going to do the same thing for the other part. So cosine of minus 36.86 is going to be equal to 0.8 and minus sine of this is equal to plus 0.6. J, once again I forgot to write down the information, the direction specifically, I. Alright, so we have the unit vectors for the solutions of B, but we need the vector, not the unit vector. So remember, the unit vector of B is going to be equal to every single component of B divided by the magnitude of B. In this case, plus by, divided by the magnitude of B, multiplied by the J direction, right? That means that I should be able to find these by multiplicating the magnitude of B. Why is that? Because if I have this and I multiplicate once again by the magnitude of B, I should be able to eliminate these two and have this answer. So for the first solution of B, the vector is going to be equal to minus 0.8, this part, multiplied by 20, minus 16, minus 0.6 multiplied by 20, minus 12. Remember, this is in the I direction and the J direction. For the second solution, I'm gonna have the same numbers but positive, because right here I have the same number as this one but with a negative symbol, and right here I have a positive symbol, this as well. So 16 in the I direction plus 12 in the J direction. And that would be all, guys. This is how you can solve this exercise, taking into account some knowledge of the unit vector and how to find some different angles.